So, Geronimo, tell us what was announced just earlier. Give me context.
So we've been planning for this. It's exciting because the first data of Mars taken with James Webb, and the most exciting things that we've been working with is we really care about how the data will look like.
Yeah.
And then when we saw the images, and you can see features on the surface of Mars, you can detect volcanic districts, and then you can see the spectra. It was very rich. We're super excited about it.
What is it telling you? What's this all about? Why is this relevant?
So the good thing about James Webb is super sensitive. So we can look at areas of the spectrum that we have not seen before. So we can look for molecules, signatures of molecules that are very difficult to do. We can do it with James Webb incredible precision. So that's our main challenge now, to go and tease all that data and see if we can look for very difficult molecules, like indicators like methane and things like that on Mars.
How long have you been involved in this project?
So we've been working, I think that maybe it's going to be more than maybe 10 years, around 10 years we've been working on this. And this is always a collection of a lot of people, people here, but also this was developed actually by Heidi Hamel. She's the one who pioneered all the solar system work, and then we are doing the Mars contribution here.
And you're based in NASA Goddard?
We are NASA Goddard, yes.
Oh, very good. Great. Okay, and it's not just a NASA project, of course, the James Webb, it's a collaboration, right?
Exactly. That's the beautiful thing about this project. I mean, for some of the instrument that we're using that provides all the beautiful spectra is a European Space Agency instrument. It's definitely also the Canadian Space Agency is involved. It's definitely a humanity success.
That's great, and it's great then that you're here talking about it at EPSC. So, Giuliano, tell me a little bit more. I hear that you understand the spectroscopy end of all this. Can you give us a little bit more detail on that?
Yes. So it's as Jerome was saying, the data are extremely rich. The instrument that is on the WST is called the NIRSpec that we use to get the spectra, and it takes it is able to collect a lot of very broad information content. When we look at spectra, in fact, what we do is to scan the light coming from the planet at different colors, which we call frequencies, and the spectra we collected have a lot of them, are extremely broad, and we can see in great detail the composition of the atmosphere of the planet, the surface features, what they can tell us about the composition of the surface, and also what's in the atmosphere in terms of clouds and things like that.
And so are you using comparison for those spectra? Do you know, like they're knowns, you've got some controls, and then based on that, then you know by your peaks what you're actually looking at?
Yes, so what we do effectively when we look at is particular GWST is particularly important to have models that are able to take the spectra and reproduce the features that we see in the spectra, and by comparing what the model can tell us and what we can see in the spectrum, we are able to tell how much of, for example, CO2 is in the atmosphere, how the clouds are made, and what trace gases like methane and HCl are in the atmosphere.
And what for you was the most exciting part of that discovery? Which of those peaks got you peaked?
Yeah, so the incredible thing about the data from GWST is that we can scan the whole planet in a matter of minutes. So we're able to produce maps of the screenshots of the composition of the planetary atmosphere and surface in a very short amount of time. And the fact that we can cover so many frequencies and so much information from a single spectrum tells us a lot and gives us a picture of the planet like we have rarely seen in the past.
And this is just a first image, right? And so you're getting all this just from one.
Yeah, this is a proof of concept. So we are learning how the planet can be observed with GWST, and what are the challenges in observing the planet.
That's amazing. So Sarah, I understand you're involved in the data part of it, which is how you're taking the data and then it's going to be spectrophotometerized in a way. Can you tell us about that process and the level of detail involved?
Yeah, actually, it was exciting. 2 months ago, we were actually observing Mars from ground base, and we were waiting for the data to come from GWST. And we got the data simultaneously, mostly like within 2 hours difference. So we were all excited to compare and put everything together. And when we opened the file the first time, we saw this amazing picture. We were like amazed by what it can do, because James Webb was thought to work on very faint object.
Yeah.
So the fact that Mars
it's so
possible,
close.
it's so close, it's so bright for GWST, kind of dazzling, right?
Yeah.
And so the fact that we actually could do this is amazing, right? So we got the first images and we start playing with them, try to clean them, try to understand what they were telling us. So we try to understand also all these images where they were located on the surface. And so we were like, oh, this has to be Hellas, this has to be this crater. And so, yeah, they match. Oh, my God, we found what it is. So that was exciting. And then for the spectra, we start processing the data, we start learning about it. We geolocate all these different solid positions on the planet. And that was exciting to understand where actually the information from the spectra was coming from. So yeah, we are here. We are learning from the data itself. We're learning from working with the people also in the STSI and team, and all together trying to understand how to get all the information. So yeah, it's a process. You're learning. So.
And is it a long process to clean the data, like you say, because Mars is so bright? Of course, you have to then find ways to compensate for that brightness in order for what you're looking for to come forward.
Exactly.
So did that take you long to figure out how to do that, how to negate the stuff you didn't want to see?
Yeah, we were trying to work on that. So we had some pipelines that trying to clean the frame first from bad pixel, from not to mask information that are actually relevant, right? And then we're processing all the different order, the different spectral information from there. So trying to get the frequency right, try to get the location right. So yes, it's a lot of work, but that's what we have to do, right?
It's very exciting. So how many hours did you put into cleaning that image?
Well, I don't know. Maybe we work hardly a couple of days, and we're still working on it. But yeah, we've been working a lot the last weeks, I'd say.
Yeah, but like if you think about it, compared to like what an orbiter can give you, it's still pretty quick. And once you get your method, you're probably going to be able to automate that in some way.
Once we get the machinery that works, we can be.
Guys. Congratulations. So now I'm joined by Francisco Gonzalez Galindo, who's going to kind of help me understand a little bit more about why this information is important in the context of Mars. So you know a lot about Mars. So why is this announcement today, Rad?
Well, first of all, because this thing has really proved that you can use James Webb to study Mars, something for it was not designed at the beginning. So they have really proved that even if the Mars is not a faint object, you can look at that, and even in just a few observations, a couple of minutes or 10 minutes, you can get a spectra for all the planet. So this really complements very nicely the information that we have from the orbiters, when you can look at a tiny portion of the planet with a lot of details, but this really gives an image of the whole planet in just 10 minutes. So it's really opening a new eye to the community to look at Mars. So they are telling the community, we have this instrument, go and look for Mars and see the amount of information that we can get with just one observation.
And say, for instance, in the past with the orbiter, how long would it have taken to process that data when they're just isolating one particular part of the planet?
Well, to have an image as the one that they have got, just 1/2 of the planet in just 10 minutes, that will take weeks or months with an orbiter. So it depends on the orbit that you have, but yeah, it's really a different way of looking at the planet, and that's the interesting thing. So yeah.
And are you excited?
Yeah, sure. So now we have to, the whole community has to start thinking what kind of observations we can make, because even in just one single observation, this thing has been able to get information about clouds, about dust in the atmosphere, the composition of the atmosphere, CO2, water, carbon monoxide. So there is a lot of information that we can study about Mars using this James Webb Telescope.
Is there anything in particular that once you heard this, you were like, oh my gosh, I really want us to look at this? Was there anything that came straight to mind for you?
Well, I think it would be very exciting to have information about organic molecules and kind of trace gases in the atmosphere, because one of the good things of James Webb is that you can look at the whole infrared spectrum. So there are regions where we have never looked at before. So this we can try to look for new molecules, and that's going to be very exciting. Yeah.
Thank you. Thanks for giving us context to this announcement today. Thank you very much.
Welcome.
So there you go. Great announcement today. You're at EPSC Congress, and stay tuned for more announcements as the week unfolds.